not surprised, not everything lasts. I've broken my heart so many times I stopped keeping track. Talk myself in, I talk myself out. I get all worked up, then I let myself down. I tried so very hard not to lose it. I came up with a million excuses. I thought
In this experiment, we're going to demonstrate how can static friction affect the motion of an object depending on the material you are working with, the amount of mass, the forces acting on it, and more important, the angle in which the motion is happening. We can see an example of static friction when we were kids and used to slip on a slide. In this example, the material of our clothes and the plastic of the slide are having contact with each other, and therefore producing friction. The variables are the following ones. The independent variables are the angle in which we position the wood surface, the material we used, in this case is cardboard, the length of the path, and the mass of the object. The depending variables are the resultant static friction, the amount of time of it to finish the track, and the forces acting on the object.
Friction is the force that opposes the motion of one surface over another. Static friction is a force that resists the beginning of a sliding motion between two surfaces that are at rest and in contact. Force is an action exerted on an object's state of rest or motion. Normal force is the one acts on a surface in a direction perpendicular to the surface, and it is always opposite to the force due to gravity. Equilibrium is the state in which the net force of an object is zero. Static equilibrium is the sum of all the forces equal to zero. Weight is the force acting on an object due to the acceleration of gravity. So we can get static friction, we use the formula of coefficient of static friction times the normal force. Force is obtained by multiplying mass and acceleration, and to get weight we use mass and gravity. To make this experiment, we use a piece of wood of 50 cm and 20 cm long, a cardboard, a tape, a wood surface, an empty container that was small in height, a bottle filled with 600, 400 and 200 milliliters, and a protractor to measure the angles.
So, for this experiment, we made several attempts, which each had 10 repetitions, in which we put a cardboard box with a water bottle inside of it over a wooden table in a certain angle in which it could slide. The purpose of this was to calculate its friction and to see how it varies. We made this attempt several times, each with 10 repetitions, and the thing that changed was the amount of water that the water bottle contained.
I don't know why you think that you could help me when you could.
For our experiment, we slowly raised the level of a piece of wood with one of our masses or a box, so that this plane could pass to different angles. At one point, we noticed that the container started to slide downwards, and it was at this point that we stopped raising our plane, and we recorded the angle at which it started moving. This is called a critical angle. We repeated this process with all three of our containers, and we actually got a critical angle for all three. being 22 degrees for our 0.2 kilogram mass, 24 degrees for our 0.4 kilograms, and 25, if I remember correctly, for our 0.6. Well, then we actually calculated the coefficient of our friction, which was easily done by just obtaining the tangent of these angles.
As each of the things we slide has different weights, it will need to be tilted a little bit more or less to get it to move. But thanks to the cardboard friction coefficient, the difference is not so great. So we obtained the friction coefficient of 200 grams, and that was 0.40. That 400 grams was 0.44, and that 600 grams was 0.46. On average, that gives you 0.43.
In conclusion, we learned that the friction is different in different surfaces that are tested for. For example, in our experiment we used cardboard on a wood place. So the average coefficient that we had, it was 0.43, while when we searched information on the internet, we saw that it was approximately like 0.3, so we were close to the coefficient. And also we learned very important concepts of friction and static force and normal force and all the forces acting on an object that can help us to understand why the friction is greater or less in some objects and in others no.
That's all, folks.